This video is for lesson 25-4, angles formed by tangent lines and secant lines. Learning goals are to describe relationships among the angles formed by tangents or secants to a circle, and then use those angles to solve problems. In the last lesson, we studied a theorem about a circle where two chords or lines intersect inside the circle. Our theorem involved how large this angle and this angle would be in terms of this arc and this arc. Specifically, we said that the measure of these angles are half the sum of the intercepted arcs. In this lesson, let's deal with this situation. We have a circle, two lines cross the circle, and they intersect each other at a point outside the circle, not in the interior of the circle. Notice that there is an angle formed. Further, notice that the angle intercepts two arcs in the circle. In this drawing, there's a small arc from M to N, and then there's a larger arc from P to Q. Now, what's the relationship of the size of the angle to those arcs? We could write a theorem for this. The measure of the angle formed by secant lines or tangent lines is half the difference of the intercepted arcs. You can contrast this with yesterday's theorem. When two lines intersect in the circle, the angles formed are half the sum of the intersected arcs. Today, when two lines intersect outside of the circle, the angle formed is half the difference of the intercepted arcs. For example, if arc MN was 15 degrees and arc PQ was 80 degrees, then the measure of this angle A out here would be half of 80 minus 15. 80 minus 15 is 65, and half of 65 degrees is 32.5 degrees. Angle A is 32.5 degrees. Let's jump ahead to question 4 and try some more samples. In the figure below, x is the degree measurement of an angle whose sides are tangent lines to the circle. So this side of that angle is touching the circle at that dot, and then this side of the angle is touching the circle at that dot. Those are tangent lines because they each touch the circle at only one point. A and B are the measures of those intercepted arcs. So this curved portion is the B, and then this longer curved portion is the letter A. Question A. Find A and B if x is 45 degrees. So let's label our angle 45 degrees. Now use today's theorem. That angle is half of the difference of the arcs. So the larger arc is A, and then minus, and then the smaller arc is the B. Multiply by 2 on both sides, we get 90 equals A minus B. Now we can solve for A and B. Here's how we're going to do that. Notice that A and B together add up to 360 because they go all the way around the circle. So over here on the side, we know A plus B equals 360. We can create a system of equations with our other equation. I'm going to write that 360 equals A plus B right underneath that first equation we had written. And then add these equations together. In algebra class, this was called combination method. This makes 450 degrees equals A plus A is 2A, and negative B plus B cancels away. Divide both sides by 2, and we get that A is 225 degrees. Once we know the answer for A, we can quickly get the answer for B. Remember that 225 minus B was equal to 90. Therefore, B has to equal 135 degrees. Now question B, find x if B is 100. So let's use the same picture take out the 45, and instead substitute the known information that b is 100. If b is 100, then we can find that a is 260. Again, the reason is that together a and b add up to a complete turn of 360. We can use our theorem to get angle x. The theorem goes like this. The angle equals half the difference of the arcs. The word difference means subtract. 260 minus 100 is 160, and half of 160 is 80 degrees. Let's try question C. Let's take out the information from our drawing and replace it with the fact that A is 270 this time. If A is 270, how much is B? 360 minus 270 is 90. Now we can get angle X using today's theorem. The angle equals half the difference of the intercepted arcs. So 270 take away 90 is 180, and half of 180 is 90 degrees. Let's jump ahead and try just one more sample, problem 8. In question 8, we're told, let x represent the measure of angle A. So inside angle A, that's where we're writing the variable x. How much is x plus angle 3 plus angle 4? Well, we got a very confusing picture. But notice that x and angle 3 and angle 4 are the three angles inside of a triangle shape. So all three angles of a triangle add up to 180 degrees. A question that at first sounds like it'd be very difficult is actually very straightforward if you look with your eyes and look for shapes that you know about. So let's summarize today's lesson. We were discussing the situation of two secant lines or two tangent lines intersecting at a point outside the circle. And we created this theorem. The measure of the angle formed is equal to half the difference of the intercepted arcs.